Hello friends, welcome to our channel. Let's have a look at today's daily challenge problem. Find missing and repeated values. This problem is marked easy by leetcode. Actually, this problem is rather interesting. So here I'm going to explain to you a trick called indexing. Our plan will be the following. First, in order to understand the problem or just practice some simple coding, I'm going to write a solution with ON space. And then I'm going to use the trick to write a solution using O1 space. So here basically we are given a 2D integer matrix called grid of size n by n. So also with values in the range 1 to n squared. I guess this is very crucial. So if you count this is also n squared elements, right? From if you have each element, so you also have n squared, right? Range, so from 1 to n squared. So each integer appears exactly once except a, which appears twice. Therefore b, there's a b which is missing. So our task is to find these two numbers, right? So this is rather easy. So for example, this one, so we need to have 1 2 3 4, right? So 2 appears twice, so 4 missing. So similarly you can look at example 2. And meanwhile here the n is bounded above by 50, right? If you consider square is 2500, and overall the problem size is not very large. In other words, it's easy, right? Indeed. However, the trick of using indexing to check repetition is very important. So now let me first write a version v1. So here basically we can use let me first initialize a result to hold the two numbers. So we need to notice the order, right? So we need to find the repeating one first, and then the one missing, in the return order, right? So let's also introduce this m just for convenience, right? So actually we can also initialize a set. So this is I for I in range say 1 to n squared plus 1. So this n squared elements form a set, right? So what I'm going to do is to iterate. So for row in grid, and then for this y in this row, then we are going to count this one. So let's use this. Let's see, we can use a counter, right? Collections counter. So the count of this y is incremented by 1, right? So if count y equals 2, we have already located the repeated one. So let's see, first we get the repeated one. So we're going to append this y here. And then each time if we find y is not, if y in s, it means it appeared. So we can actually remove this one as remove this y. So this way we are going to get all the numbers which appears. Then in S we will get one element, which is the one missing. So what we can do is result append. So we can do S is a set, right? We can pop the unique element. And then we can return the result state. Let me first check it's right, accepted. Yeah, it accepted. Now let me explain this one using indexing. So actually this is very intrinsic to this range, right? So if we use this number as the index, so we just shift it by 1 using 0 indexing. So I'm going to directly write the solution. So once you see the coding, you understand the logic. So actually this kind of problem also appeared when you are given a one-dimensional list, right? So now basically we use the positive sign and negative sign with indexing to check repetition. So what we do is this. We have this length, right? That's great. And then we have a result, so which is we want to return its final state. So here for I in range n, let's scan it. For j in range n, then I'm going to check this number. So this number will will be absolute value of grade ig minus 1. The reason why we use absolute value, because we are going to modify the value of in the grade so that we know which is already seen, which is not. So if we use this one, this number will be in between 0 up to n squared minus 1, both sides inclusive. Then actually we can use a sign in this grid to represent that, oh, we have seen this number grade ig. So how do we do this? We can get this num, because we have n rows, right? If we have m rows, so we can modulo m, divide integer division by m. Then also we have this, so we can do this. That's much better. So what I want to have is num divided by n, and then num modulo n. So overall we can write like this: dev mode num n, right? So then if grade rc is less than 0, it means that I have already seen this number. So then we can do result append num plus 1, right? Because this is the relation, because all the numbers are positive ones, because we use sign to indicate its appearance. This is the one. Otherwise, so we haven't seen that number yet, but now let's see. We change this index rc, right, to make it a negative number. So, right, so this negative means so the corresponding number, if you retrieve this will be appeared. So this is the one. So this loop will give you the number that actually appeared. So now let's iterate again. So say for r in range n, for c in range n again. If grade rc is greater than 0, so it means that we haven't seen this number, right? So what we are going to append will be r times n plus c plus 1. So this is the relation, right? So if you have a number, so then you do division, integer division, you get the r and c. Then from this rc, you multiply by n, then plus c, because here we are minus 1, we plus 1 back. Then you get the number we haven't seen. Then we just break. So this way, we are going to return the result. So let me first run it to see it accepted, and then submitted that. Yeah, it's very fast. Actually, this is O1, right? O1 in the sense that we just here this contains two numbers. So, but this is what we want to return. I guess that's the main coding. Let me give a quick summary and then give you a quick walkthrough of this second method. So here we are using index and sign to do this. So this is the O1. So basically what we have done is this. If you have a number, say grade ig, right? And then I'm going to transform it to, because we are going to change sign. It can be positive, it can be negative, but we just use positive, right? And then we this one, because this number is in this range, and open, let's see, a closed interval between 0 and n squared minus 1, right? And then this can be used as indexing. Then I map it to this index, rc. How do we get the rc? It's dev mode. Let's call this number y. So y into the division by this n, right? So the position, we can assign it a sign. For example, change the sign. Change sign of elements at rc, right? So if you do the scan, if you see the number at this position is negative, it means, because this one you can revert back. If you have rc, then r times n plus c, then plus back this one. So this basically recover this original grid ig, because there's a sign problem. If you talk about absolute value, it's very right. Then basically it tells if you have seen this number or not. This is the core idea. So with that said, I hope it helps you to digest this second method. So you are also encouraged to try similar method for checking repetition for a list, right? So here we are given 2D list. So how about 1D, right? Actually, the problem is easier. So you have a list, or you have an array. Let's see. Length is n, right? The supposed element is in between 1 to n, both inclusive. And then you also find if there are repetitions and missing, and how to locate them. Exactly the same idea, right? So with that said, I hope you have learned something new, or you have practiced, make yourself more familiar with this kind of indexing and sign retrieval. Thank you for watching.